Yesterday, we discussed our final topic necessary before we embark on our final STEM challenge. Remember, our challenge this year is to create a device that can keep an ice pop cold for an extended period of time without the use of a freezer or additional ice. In the beginning of our time together in enrichment, we went over what was called the engineering design process, or that 5-step process that we are going to use to solve problems. Our engineering design process required us to ask, explore, model, evaluate, and explain. Right now, we've been completing that ask step of the engineering design process. We needed to both understand what our problem is, that our ice pops were going to melt, and develop the necessary science background knowledge needed to successfully complete the challenge of creating something that can keep those ice pops cold when they're exposed to hot temperatures on a sunny day without a freezer. So let's talk about some of the topics that we covered. The first thing that we did was we discussed different types of inventors and inventions. We looked at Cassidy Goldstein's invention of the crayon holder. When we were discussing Cassidy's invention, we spent a fair amount of time focused on her blueprint. We discussed how important it was that her blueprint was so detailed. Think back to some of the things that we noticed. We talked about how even though none of us have ever met Cassidy before, by looking at her blueprint, we can take a look and see exactly what she wanted to create and how all of those parts of her invention would fit together. We talked about some of the properties or characteristics of this crayon holder. We then used that term, properties, to discuss our monster trucks. We were focused specifically on the color and the texture of our trucks. Take a look at the detail in some of your classmates' work when writing and recording the details and the textures noticed when we did this activity together in class. Even though we don't have those monster trucks in front of us, we can tell by looking at different parts of these pictures, like the wheels, how they feel. We can tell by different properties on the bodies of the trucks, like the designs that are included in these drawings, what these monster trucks look like. Once we completed this activity, we talked about the importance of color and the science behind how we see different colors. Using that knowledge, can you remember when we are building our device to keep our ice pop cold, are we going to want to use dark colors that absorb the sun's light and heat? Or would we want to build with light colors that we said do a good job at reflecting the sun's light and heat? What do you think? If you said light colors, you'd be correct. Remember, we talked about how we typically wear darker colors in winter months and lighter colors in summer months. Those lighter colors help to keep us cool. We then focused our conversation towards the idea of matter. Remember, we said that matter is anything that has mass and takes up space. We then discussed the three main types of matter that we come in contact with most often: our solids, liquids, and gases. Looking at this image, what state of matter is the juice in my cup? Now take a look at this image. What state of matter would the bubbles in my drink qualify as? Lastly, take a look at this chair. What state of matter would you say my chair is? From here, we then discussed permanent and non-permanent changes in state of matter due to temperature. Is ice melting to form a liquid an example of a permanent or non-permanent change? What about an example of taking liquid batter, placing it in the oven, and getting solid cake? Is that a permanent or a non-permanent change in state of matter due to temperature? From here, we discussed the idea of thermal conductors and insulators. Would my metal pan be an example of a thermal conductor or insulator? What about the glove that I put on my hand to touch that metal pan after it has been exposed to heat from the stove? When I'm building my ice pop cooler, am I going to want to build with materials that act as insulators or conductors? Would my ice pops melting be an example of a permanent or a non-permanent change in state of matter? Think about these questions as you head to the next activity.